the paper next to you, try to draw. This is for cluster, this is for stratified. Visualize it. It makes you understand things better, yeah? Okay, now, for this part, right, selected group means selected clusters, yeah? In this case, you may have like 10 clusters, but you do not need to sample from each and every one of the 10 clusters, right? You just select a few. How many? You will learn that later. Then, for the next layer of selection, so first you select the cluster, right? And then the elements. Okay, you can select each and every element in the selected clusters or the selected groups. Okay, or you can select a subsample of elements, meaning that within the selected cluster can then sample, randomly select within it instead of taking every one or every element within the selected group. Okay, that's why you see chapter 7 is cluster sampling, right? And then the last chapter is, what is it called? Multi-stage cluster, something like that. That determines it. Right? Okay, now elements within a cluster should ideally be as heterogeneous as possible. But there should be homogeneity between cluster means. What do you understand from that? She said from cluster to cluster 1 until cluster 10, in this particular example, right? If you were to compute the mean within each cluster, they should be about the same. Right? So it's talking about homogeneity here. It's homogeneous. It's almost, it has similar characteristics from one cluster to another. Okay, any questions so far? Confused or excited? You decide what you want to be. Huh? Okay, sleepy, is it? Okay, I was sleepy also. Yeah. Before we begin, I was, oh, I'm going to teach this guy. I'm so sleepy. But then by 10 o'clock, my eyes are wide open. All right, probably excited to teach you guys. Okay, so next, each cluster should be a small scale representation of the entire population. That's the key thing. So in my head, I see this. Each cluster, right? It's like a mini population. Each cluster is a mini population. Is stratified like that? Each stratum a mini population? The easiest thing to remember, right? When we talk about stratified, you think of, clinical trial, cancer stage 1, 2, 3, 4. You must segregate like that because they all respond differently to treatment, to drugs, chemotherapy, etc. Okay, that is for stratified. But for cluster sampling, each cluster is just a mini population. So if you have like 10 clusters, you have like 10 mini populations. And the beauty of that is what? Now, the clusters should be mutually exclusive and collectively exhaustive. Meaning what? It doesn't overlap, right? The elements. You know what mutually exclusive means, right? If you draw the Venn diagram, the rectangle box, Venn diagram, yeah, in that universe there. So mutually exclusive means what? Is there any overlapping? Any intersection? Oh, they're just like circles, 10 circles in the box, 10 balloons floating in the box. No overlap, no intersection. Correct. And collectively exhaustive, what does that mean? Exhausted, you know that, right? Okay. Now, like collectively exhaustive, meaning that there's no other possible clusters there. Like everything is, that's it. You have exhaust all resources. You have collected everything, and just 10 clusters. That's it. No more. Okay. Right. A random sampling technique is then used on any relevant clusters. In this case, I think I prefer to say in use on the selected clusters, right? Wait. A random sampling technique is then used on any relevant clusters. Yes, true. Relevant is the correct word. To choose which clusters to include in the study. Okay. The process, yeah, the sampling. Okay, so far, you guys can visualize this. So I didn't draw anything here, but I hope you're sketching on your paper or just draw it in your head, yeah? Okay, any questions so far? We are on slide 3. And it's only 10:22. Okay, can follow so far? Right. Now, in a single stage cluster sampling, which is what we're learning in this chapter, all the elements from each of the randomly selected clusters are used. Everything within that selected clusters. Okay. Sounds easy, yeah? Is it? All right. So how do you actually select a cluster sample? A cluster sample. Okay. First, of course, you need to specify the appropriate clusters. All right. So if you see for COVID-19 cases, they based on what? Based on the origin of infection, isn't it? They have cluster this taman lah, cluster that taman or that company, whatever. Because that's for the tracking purposes, and also if it's the same cluster, then you would expect it's going to be the same variant. Yeah. Now, elements within cluster are often physically close together. True or not? Let's say schools, right? There are many schools. How many schools in Malaysia? I don't know really. Thousands. Okay. Several thousands. I don't know, tens of thousands. But within each school, right, the elements, we're talking about the students, right? Within school, elements within cluster, students within school. Often physically close together, true or not? Because school, right, if you live here, you cannot register for daily school. Of course, if it's boarding school, it doesn't matter. But for daily school, must not exceed certain distance, isn't it? Yeah, certain kilometer radius from the school. So they are, in other words, the students are physically, mean at the house, physically close together. So meaning what? They tend, as I said, the tend, not always, but they tend, having the tendency or more likely to have similar characteristics. So in other words, they'll be highly correlated. So the amount of information may not increase substantially in that sense. Now, if the elements are very different, then you can have to sample a few large clusters in order to get a very good estimate of the population parameter. Okay, still blah blah. Blah blah, then you gotta read the examples, the case study in the textbook. Yeah. Okay, so after you specify the appropriate cluster, now next, compose a frame that lists all the clusters. So before this, we're talking about a sampling frame, listing all the sampling units. For cluster sampling, you compose a frame that lists all the clusters. So if a state, let's say a small state, has like 50 schools, so now you have a list of all the 50 schools. Okay, so do you have to go to each of the 50 schools? If you were to do SRS, instead of cluster sampling, imagine you probably, like all over the place, right? But now, using the beauty of cluster sampling, it simplifies your data collection. So you see number 3, select clusters using SRS. You're not going to go through all 50 schools. You're just going to select a few. Randomly select the schools. Does it matter which school? Not really, isn't it? Because in cluster sampling, what's the assumption? each cluster has similar characteristics to one another. Right? Remember, each cluster is a mini population. Right. So how to actually draw a sample? Okay. And this is an example of industry. So suppose clusters are formed by boxes of components coming off production lines. In other words, one cluster of components per line. Right? If all the production lines have approximately same rate of defects, then the components in each cluster or in each box are about as variable with respect to the quality of the population as a whole. Okay, so far? Now, in this situation, now a good estimate of the proportion of defectives produced could be obtained from one or two clusters. Yeah, very few. Okay, let's take an example here. Now, a sociologist wants to estimate the per capita income in a certain small city. However, the list of resident adults who have income here is not available. So, how should the design of the sample survey be done? The elements here would be the adults, right? Remember elements? The subject where you get the measurement or you get the data from. So in this case, data that we need is what? The person's income, isn't it? So we assume they're all adults, right? So the adult's income, the resident, adult income. So the element is the resident adult. But there's no list of adults there. So if there's no list of the elements, in other words, no sampling frame in this case, you cannot use SRS, isn't it? Stratified also cannot. Cluster is possible. In fact, cluster is probably the option that you have. So again, this is so US centric, yeah, the textbook. So this example, city blocks can be considered as clusters. Okay, or over here is probably all the tamans, and each block has the same characteristics. That is a fair assumption. Yeah. Because the cost of living per residential area is about the same. So you would expect that the people living there will probably have, in the certain range of income living there. Okay, of course there's some outliers, but in general. And then also you can use the list of city blocks there. That will be your list of clusters. And then you use SRS to choose the clusters. Are you guys still with me? Or am I teaching myself here? Okay, all right, good. Now, cluster versus stratified. Cluster is treated as the sampling unit, so analysis is done on a population of clusters. Okay. Now, in stratified sampling, you have to visualize this, guys, focus. This is very important. In stratified sampling, analysis is done on elements, isn't it, within the strata. So in stratified sampling, a random sample is drawn from each of the strata. If you have 10, then you must take a sample from each of the 10. Whereas in cluster sampling, only the selected clusters are studied. So in cluster sampling, out of the 10, you do not need to sample from each of it. You're probably just going to sample from 3. Why? It's going to be biased. Is it okay? For cluster sampling, remember, each cluster is identical, isn't it? It's a mini population, but for stratified, they're very different. Each stratum is different. It's got its distinguished features. Okay, now the main objective of cluster sampling is to reduce cost. How? To increase the sampling efficiency. How? We learn further. Now, this contrasts with stratified sampling, where the main objective is to increase precision. Okay, you guys are pretty quiet today. Okay, maybe it's time to take 5 and go wash your face, or make some coffee or something to stay awake. Yeah. Because this is very important. Yeah. Okay. All right, guys. Let's take 5. We pause here. Yep. Okay. Go ahead. Do some stretching. Look at some object 20 feet away for at least 20 seconds. Focus. Yep. Okay. Take care of your eyes. Hello, welcome back. All right. So moving forward now, any questions before we continue further? No questions. I have one question here. Does anybody knows what happened to Tashwini? She hasn't missed the class before. Okay, no one knows. All right. Okay. Hopefully everyone is safe and healthy. Yeah. Okay. Any questions so far, guys? You guys can still hear me clearly? Yes. Okay. Thank you. Right. So, I guess we shall resume then. Just resume recording here. Okay. Is it now clear to all of you the the differences between cluster and stratified sampling? The conditions, so the scenarios, they're very different. Why I emphasize so much on this, because this is the most often confused or misunderstood sampling techniques. These two, they swap. Either they swap or they think that it's the same. Okay. Not just for undergraduates. I've seen postgraduates also like wrongly, um, you know, identifying the sampling technique. Okay. How not to be confused? Start drawing your own examples or your own diagrams on how to distinguish between these two. Okay. Now, remember, well, if actually if you read the textbook, they talk about within stratum and within cluster, what are the characteristics. So here, as I emphasize here, remember for stratified, each stratum, okay, is very different from one another. Remember, cancer stage 1, 2, 3, 4, or the COVID-19 by the variant, very different. The way the characteristics of the elements and they're very different because of the different conditions, different environments, different everything there, different characteristics. Okay, each and every stratum. Okay, so like between strata, that's why you can do comparison between strata because they're very different. Is that the same with clusters? Clusters totally the opposite, isn't it? But remember the schools? If you're talking about schools, you could probably need, it's under the same state, let's say. They got the same budget, the same. Of course, you cannot compare between public and private. Different funding, different structure, different characteristics. That one you have to stratify lah. Because they're different. But let's say public school, the government schools. Okay, sekolah kebangsaan. And it's within the same district. So you've got 5 schools there. You would expect that they have similar characteristics, isn't it? Same budget funding, same structure, the students who attend there is students from within the same district. So you expect them to have about the same characteristics. So with cluster sampling, each cluster is similar to one another. Mini population. Because the whole population will be made of those, let's say, those 10 schools, that's the whole population of interest. 10 schools, 10 sekolah kebangsaan within this district. District 12. Oh, Hunger Games. Okay, now, but from district to district, it's going to be different, probably, in some aspect. But within the same district, all these 12 schools have similar characteristics. So that should simplify your sampling, isn't it? Instead of going to each and every school, total of, let's say, in this case, 10, you could randomly select maybe 2 or 3 schools. Now you just go to 3 or 3 schools. That's why you look at the pros and cons, right? First, you have to understand the procedure or the differences between the sampling methods first. And it's easy for you to generate or think of the advantages and disadvantages. The pros, what? It is cheaper. It is cost saving. Faster sampling. Why? Because there's fewer travel expenses, lower administration costs if the cost of getting a sampling frame that lists all the population of elements is very high. Or in some cases, they're not even available. Or, it's impossible to get the list of elements. Remember the example just now, the resident adults? Who's going to keep, because people who live in them. So it's either it's difficult to obtain, it's very high cost, things like that. Secondly, cost of collecting data, as you know, right? I mean, logically, cost of collecting data increases with the distance separating the elements. True or not? The further it is, the further the elements from each other, and let's say if for some studies that requires interview, personal interview, then it's more costly. Yeah. Okay, no brainer, that one. Okay, so next, how about the disadvantages? It could, if not well conducted, it could lead to higher sampling error. Okay, and in that case, it will be difficult to measure. Right, as you read through, right, as we go through this chapter, think of the main difference between the optimal construction of strata, means how do you identify the strata, and also the construction of the clusters. Okay, what will be the best case scenarios to identify the constructor, different strata, and also the different clusters. Excuse me. Un momento. Okay, just needed to drink water. Okay, guys, 7.3. How do you estimate the parameters? Okay, now stay tuned, stay focused. The notation for this chapter and also chapter 8 next, quite different from all the earlier chapters. Okay, but remember all these notations are available in your list of formula, yeah? Okay, so please refer to your list of formula when you answer your quiz and your test. Okay. Right, so what is the big N here? All this while, the big N was the population size, right? Over here is also the population size. But in what context? Instead of the individual elements, it's actually the total number of clusters in the population itself. Okay, get used to it, guys. And correspondingly, or accordingly in this case, the small n is the number of clusters selected. So your sample, right? Your sample cluster. That is the small n. And then we have new notation. M subscript I. The number of elements in cluster I. So number of elements in each and every cluster. Of course, it's going to be from 1 until the big N. Okay. Now, M bar is the average cluster size for the sample. And this is, of course, given by summation of all the MIs divided by N, which is the sample cluster. Big M will be the number of elements in the population. Okay, so that notation there. Okay, you guys following so far? Stay tuned, stay focused. You owe it to yourself. Yeah. So the big M bar would be the average cluster size for the population. Yi is the total number of all observations in the ith cluster. More confusing, is it? Okay, let's try see one example. Okay. Now you have to trust your your brain power, your God's creation. You are capable. Right. So estimator of the population mean mu is of course what we call the sample mean. Is given by y bar, and as usual, the formula is actually just the same thing. It's like sometimes you use different notation. That's why it's important to understand what that means. Yeah. Okay. So this is the summation of all the, let's say if it's a ringgit, amount of money you spend on meals, and it's everything there, and you divide by summation of what is the MI again? The elements in the sample, isn't it? Okay. So the estimated variance of, that's typo there. Guys, that's not estimated variance of mu, that will be estimated variance of y bar. So you have your slide printed out, please change this. I will correct this slide later on. Because it's based on the subscript there, right? It is y bar, the estimated mean itself, not the population mean. Of course, you assume that they're identical. Okay, where again, as our square is given by this expression, and okay, take note. If M, the big M, if the total number of elements in your population is unknown, then you can estimate the capital M bar. You can estimate it by small m bar. Okay, that's what we do in statistics, isn't it? If it's unknown, then we estimate, make some assumptions, valid assumptions. Now, estimated of the population total, or the TOR, is given by this expression. It's also similar, but now you have the capital M there instead of the all the previous chapters. It was the big N, isn't it? N. Now you have capital M for Malaysia there. Estimated variance of capital MY, which is the population total. This case is given by this expression, also very similar, isn't it? And the estimated MY bar, note, is useful only if the number of elements, the big M, is unknown. Okay, guys? If the big M is unknown. Okay. One example. Let's say interviews conducted in each of 25 blocks sampled from 415. Remember, what's the big N here? Anyone, what's the big N here? Uh, well, the question gives me that, meaning that what is it? That's just the equation. Big N equals to 415. But what is this N? What is it? What would be the units for this big N? Yes, total number of clusters, or in physical, common layman language should be 415 blocks. Okay, remember the study of income? You have no list of resident adults, but you have a list of 415 blocks in the city. Okay, guys, put in context, huh? Okay, numbers, that one's all mathematics. Yeah? Mathematicians, I know that all mathematics, numbers, all mathematics. But statistics, beauty of statistics is you tell a story using those numbers. Okay, and you predict, you estimate based on uncertainties. Of course, some theories, which is what you're learning now. Okay, guys, put in context. Do not be robots, it's just 1010, or you just have numbers and equations. Tell the story. Okay, so now the data on incomes are presented in the table next to. So use the data to estimate the average per capita income in the city and place amount of error of estimation. Typical question, isn't it? Oh, okay. So when there was blank, did you guys sum up? I know in your slide, this is blank, right? So you see this table where there's a blank cell. I call it cell. I'm so used to the Excel terms. Or blank space. I always wonder what that blank space is for. And I usually fill up the blank. Right? And usually, well, it should be one of the things that statisticians are like intend to do. We have the tendency to do that because when you see like this is incomplete story, isn't it? Numbers, incomplete stories. You always when you were young, right? Remember those days when you had duit raya, you had ang pao, you can't wait to add up, right? And then compare with your brothers and sisters who got more. Okay, and you probably then prioritize, oh, this uncle gives so much, this auntie give more, so probably the next time round you go to the auntie's house first. Okay, that's your strategy perhaps. Okay, think of those good old days, guys. Come on, still remember. Yeah. But of course, during my time, like getting 50 cents, the 50-cent coins, it was like, oh, a lot already. If anybody gives 1 ringgit, oh, that's your favorite person. Back then, in the 70s. Okay. Now, of course, like 1 ringgit also, like, what can I buy with 1 ringgit? Even teh ice is 120. Okay. All right. Okay, so you're getting the sum of 74. Okay, is that just one side or did you add up the other side as well? We have a total of 25 clusters. So the MI, you add up for all 25, right? Okay, no problem. Right, so take note, did anybody verify the numbers here? Not enough time, is it? Yeah, I gave you the slide so late. I'm so sorry for that. For the next chapter, inshallah, I will give you much earlier. Yeah. Okay, thanks a lot for verifying that numbers. Okay, good. 151 and 1329000 is also correct. Yeah. All right. So that's the thing. Let's move to the next slide, I guess. And then what do I do next? We'll look at the formula. What are the values that you need to compute? So to answer that question. So from the table just now, you're going to have to add this, isn't it? Yi minus my bar. Okay, what was the my bar just now? Okay, so you have all this, right? Oh, there's also blank down here. Fill up, count your duit raya, count your, add up your ang paos and all. Okay, next. Now virtually only, okay. Right, so summation of mi was 151. So you can get the y bar. Now, the big M is unknown, isn't it? You only know the big N, which was what? 415, right? Total number of blocks, which are, you have like 415 clusters, but out of this 415, you only select 25 clusters, isn't it? Is it going to be biased? It shouldn't be because they are identical, right? They have similar characteristics. Remember, there's a key thing with cluster sampling. Okay, so you got your y bar. No, big M is unknown. So you assume that the average the big M bar is the same as small m bar. And small m bar is given by what? Of course, the summation of mi divided by the number of clusters, isn't it? 151 divided by 25, you get 6.04. Okay, any questions so far, guys? Gonna go slow on this chapter. Yeah? Alright. So what next? You're gonna have to add up using the formula, or you can just use a calculator, isn't it? So you should be getting that value. Okay, I hope someone will verify that calculation here. Okay. And then plug it in, and please be very careful. I honestly, I've made mistakes also, and not just once. I've made mistakes multiple times as well with the manual calculation. Okay, so now I have an Excel file plug in on this. All right, so the bound of error in this case, 1617.13. Okay, guys. And that's your job. If you notice on each and every page where you have all this, I put that interpret. So please write down your interpretation. And don't just always copy the same sentence and just changing the values. Don't do that to yourself. You're far more capable than that. There are many ways to tell a story. Okay, just make sure that it's correct. And if you read the textbook also, they got different ways of describing the mean and also the bound of error. What does this bound of error means? Okay, you can relate to confidence interval more or less, or you can give the actual unit, and whatever it is, when you interpret, avoid using technical terms. Okay, so if it's mean, how are you going to interpret? You can use the word average because everybody understands average. Yeah. Okay. Right. So I'm going to stop there. Actually. Any questions? At least, right, by now, I think that you can distinguish clearly between stratified and clusters because they are very different. Okay. I'm going to go straight to the last page because I want you to be thinking about, no, end lah. Okay, thinking about this because this will conclude this chapter. Compare and contrast between cluster sampling and stratified sampling. This is very important. Do your own notes. I know I put that teamwork, but everybody's got to do this on your own and then discuss as a team and then come up with, the best possible answers. That's the thing. That's what we call the team synergy. Okay, individual You have your own talents, you have your own knowledge individually. But if you combine forces, right? You combine your answers, you discuss through, you understand better, and you can come up with the best possible answers as well. Okay. So first thing, as with everything in life, right? I don't know. I mean, like you guys are quantitative science undergraduates. You know, like it should come naturally. If it doesn't come naturally now, you got to practice. Okay, you got to practice. So first thing, I mean, this is basics of learning. I think. Yeah, if you agree. I know when you were small, you do this a lot, but now I know life gets harder as you become older, isn't it? But well, life is a test. Yeah. So similarities and differences. That's the first thing. And then think of the homogeneity within a stratum. Why within each stratum it's similar characteristics? Um, not why similar characteristics. I mean, what happens? This is to distinguish between the two. And then within a cluster, you have heterogeneity. Heterogeneity. It's difficult to pronounce, isn't it? Okay, so in other words, they're not identical. They are quite different within a cluster. Okay. And what happens to the variance within a stratum and variance between strata? And similarly for cluster, variance within a cluster compared to variance between clusters. Hypothetically, yeah. Okay, and there's a lot of theories in here. Okay, this kind of questions is intended for you to think and to come up with the answers so that you understand the scenarios. Really, part of your final test 3, you're gonna be given scenarios and you need to identify which is the best sampling technique. So it's very important that you understand. So that's a cost learning outcomes, right? So that you know you can apply suitable sampling techniques given particular scenarios. All right, guys. Now discuss also 3 common applications of cluster sampling. I've given a few, like the schools examples, and also example the textbook, but try to come up with your own examples, or at least you create the scenarios by yourself. For exercises, you see the textbook coverage is actually slightly a bit more than what we're covering here in the syllabus. So probably you want to try to pass your exam papers instead. Okay. Take note that some past year exam papers also so questions are quite similar to the ones in the textbook. And the textbook has got answers to some of the questions and selected answers. Answers to some selected questions. So yeah, you can do that on your own. Okay, I'm not going to dictate which question this time around. Okay. Any questions for me? For now? Nope. Okay. So we have 14 minutes more. What would you guys like to do? It's 14 minutes. Do you have questions for me? Do you want me to do a breakout session for you to discuss on your group project? Or would you like me to end this class early? Or what? Don't be shy. Be honest. I mean, I'm here. So you have questions and your test 2 on Tuesday. We'll cover chapter 5 and chapter 6. I think probably for chapter 6, you guys are pretty much confident. Well, all of you pass, and by far that's the best performance. Oh, Tashwini, you are here. You're not in the attendance.
I just joined in. Actually, I joined in quite late because I had internet connection. So sorry.
Okay, no problem. Make sure you catch up on what you missed. Okay, I'm gonna add you
Sure,
manually.
ma'am, will do.
Okay, all right. So there's okay. probably end. Okay. Yeah, someone send me. Okay. Yeah, we can end early. No problem. But no, promise, no, don't promise me. Promise yourself that you'll be fair to yourself that yes, there's this 12 minutes, we end this class earlier. Make sure sometime today or tomorrow you allocate at least 12 minutes to go through sampling techniques, whether you can spend that 12 minutes as part of your revision as well, for the test. So chapter 5 and chapter 6. So chapter 5, the calculations, I think we did quite a lot in class, right? Ratio, regression, remember the scenarios for each. Yeah. Okay, and be careful with the calculation practice, right? For systematic, it's relatively easier than the stratified or whatsoever, which was done during your test 1. So, okay, then we end early then. That's okay. Any objection? I forgot to ask. Any objection? Please PM me. Please say so now. No objection. Everybody's happy to end early, right? Probably catch your breakfast or take a shower before your next class whatsoever. Okay, whatever you do, again, freedom with responsibility and the flexibility. It has to come with discipline, Okay, you're all adults here. I'm trying to treat you as mature adults, responsible adults, and disciplined adults. Right? Okay, so thank you very much. If you guys need to consult me on your group project or anything, please PM me, no problem. Okay, all right, thank you again. Take care, all the best, and make sure don't come late. Be prepared for your test too, yeah. Oops. Okay, thank you very much, guys.
Thank you,
Assalamualaikum.
madam.
Take care, stay safe. Yeah, ultimately, health, safety, number 1. All right, bye bye.
Madam,
Yes.
yes, I want to ask page 15. Just now we need to do interpretation, right? So, if we do we need to include the M bar in our interpretation? Like if M bar is average, average cluster size, right? So,
Yeah.
how to interpret the M bar? It's like
Oh.
average. The number we get is the size, the cluster size.
Okay, when you interpret, right? Just interpret to answer the question itself, the final answer. So in this case, average per capita income and the bound of error. Only these two.
So we do not need to include the size.
No need. Okay, but you can mention that because in this, no need to mention. Yeah, just basically, I'm showing here, right? So basically, just interpret what it means. The average per capita income and a bound of error.
So if we need to interpret the M bar is like average 6 interviews in each cluster. The meaning of M bar.
Go back to okay. The meaning of M bar. So this is per block, right? About 6. About 6 per block. Yeah, that's part of your story, but you do. Yeah, to understand, yes, but for the interpretation, just go back to the question. Okay, meaning you need to interpret the average per capita income and the bound of error. What does it mean?
Okay.
Okay. All right. Thank you for asking.
Thank you. Bye bye.
All right. Okay. Bye.